So it's going to get a little bit more complicated, but you guys already know about attributes and point sop and all that kind of stuff, right? So this should be a piece of cake. Right, let's see. Okay, so now we need to actually single out the part of the building that's colliding. Okay, so I've got my saucer over here, and let's get our brains in a problem-solving mode. It's 10 o'clock, kind of waking up. Okay, we're gonna have to do some serious brain work. Okay, so if I've got my saucer going through the building like this, how do I eventually determine what part of the building needs to be fractured more? How am I going to do that? Let's come up with some ideas. Let's brainstorm. Brilliant. Okay, that is what we're going to do. So yes, we are going to. The problem here is that the saucer it's not touching at all here, is it? And it's touching here, and it's not touching at all here. So we need to actually time shift it to the place where we know it's going to get the collision that we want. Okay, so we've got both distance and we've got time. You guys already figured it out. Okay, that's all we're going to do. Good problem solving there, guys. Okay, so all right, so I'm going to time shift this saucer to the moment of impact. All right, so I'm going to which SOP do I use for that? Yep, time shift. Okay. Time shift. And here's a nice little expression. So let's see. It's going to impact, let's say, on frame 39. So I could either hard code this to frame 39, and then I'd have to dive into my network or all that stuff every time the impact point changed. If I just wanted to visually see a little better what was going on, I can use an expression called op digits. Okay, and right now it's going to be time shifted to frame 1 because my node says time shift 1. So here I'm going to say, I'm going to label this node impact on frame 39, and it's going to shift to frame 39. So op digits mean the operator, what are the digits on it? Okay, there we go. So now, no matter where it is on my timeline, it's going to go to frame 39, okay? That's our impact point. Okay, now, distance stuff. Okay, we can use a node we've used a little bit before, which is the attribute transfer. That's that overlapping stuff you guys just suggested here, okay? So, attribute transfer. Now, if I were to make this guy red, and I were to make the building white, okay, and I attribute transfer onto the building my saucer, it's going to have red show up there. But the problem with a color is that it's really not too specific. And that being said, many guys have been doing Houdini for a lot longer than I have, use color to do stuff with, but I think that's generally, bad practice, because color, it could mean so many things. It could mean the actual color they want it to be when it rendered. It could be a certain previs mode. So I actually like to name it something in particular as to what I'm working with. Okay, so instead of actually singling out these areas with color, what would be a little more controlled way to do that? A color in Houdini is an attribute. So by adding this point sop, I've added the CD attribute. Okay, so I don't like to keep things in CD. I think it's very non-descriptive. It doesn't really go with the workflow of setting up a system. Okay, so instead of that, I'm going to make my own attribute. All right. So I'm going to use, I think we've used this, attribute create. Okay, so now this flying saucer has attribute 1 on it. Okay, but what would be a good name for this attribute? Like it's not color, it's not attribute 1. What could I call this attribute? What are we doing with this attribute? Yeah, it's kind of like it's telling us where it impacts, right? Its overlap is. Okay, so you could call it overlap, you could call it impact. I'm going to call it collide because that's to me what that represents is, you can call it whatever you want, but I'm going to call it collide. Okay, so now I have the collide attribute. Okay, and by default it's all 0. So if I look at my spreadsheet, this is each point on my geometry. Point 0, point 1, point 2. This is the collide attribute. Right now they're all set to 0. Okay, I want these guys to be set to 1. Okay, so everything on my spaceship is going to have a value of 1. Everything in my building is going to have a value of 0. And that way when I transfer that attribute, I know what's overlapping, let's say. I can use op digits on this too. So I'll call this attribute attrib collide 1 op digits. See, now it goes to 1. My next one, attrib collide 0. Now I know I'm setting my building to 0. Okay, so I transfer from onto my building. I'm going to transfer the saucer at rest with that. Under attributes, I don't need primitives, I just need point attributes, because notice this guy is a point attribute. It's an attribute on every point as to every polygon. Okay, and I'm going to only need to transfer collide. Okay, so you can save system speed if you only transfer the things you need. It might not seem like a big deal with geometry like this, but once you start talking about 1,000,000 polygons, it becomes a big deal as to what gets transferred and what doesn't, the computational time. Okay, so now I'm transferring collide. Cool, but I can't really see it too well. So now I'm going to visualize that. So I'm going to use a point sop, and I'm going to add my color. This guy will be 1. The red value will always be 1. And then I'm going to go between red and white by 1 minus collide. See, so it's 1 minus collide, 1 minus collide. That gives me a red to white blend. And I can see where it touches. Okay. So on my conditions, we can adjust the blend width here. I'm going to say I want it to blend a little more. Okay, so that's the region of my building I want to turn into high res. Okay, so a few things there. Time shift. An attribute, this guy's 1, this guy's 0. Transfer that attribute from your saucer to your building and preview the attribute so you know what's going on. Alright, you guys got it? Alright, so this part of the network right here. Let's give that a shot. So yeah, funny little story. So a few questions were asked about why we're viewing, like, why we're setting this color here. And it's purely for visualization, okay? So I want to preview the result of what I'm doing. I want it to be named something logical like collide, but I don't want to just go off of, like, guessing as to how big that is. And I also, you could transfer color at the same time, but I think it's just a good general practice to view things downstream. And by downstream, if you view this whole setup as a river, you always want to view the thing that's already there. You don't want to, like, maybe it's some logic's off and the color doesn't directly correspond with what you're doing. So downstream is always a safe way to really make sure you've got it right, because I know that if it's red, that means that collide is present. Okay. Now, funny story. When I was working at Rhythm, I built what's called a digital asset. It was to make like a snow tornado on Mummy 3, and I wasn't there in the morning, so I guess part of the team had to pick up that asset and try to use it. And it was a pretty simple digital asset, that made this tornado. So they had the snow working and everything when I got there, but they couldn't figure out the color because I had just the idea was I had this spinning sphere, or it was something like a sphere, and you know, to make it spin, I just, you know, I put a color on it so we could see it spinning. So I did like TX, TY, TZ for the color, and the thing was just like spinning around. Okay, and they spent the whole morning trying to figure out what the color was doing. And when I got there, I was like, guys, the color isn't doing anything. I just kind of put it on there just so you could see it spinning better. They're like, no. So yeah, the color is one of the most misused and misunderstood things that people use it for, and that's why I don't think it should be used. I think it should be stored in actual logically named attributes, so you can really see, you know, exactly what's happening. If there is color on something, maybe it means something, maybe it doesn't, but I don't know. People have different opinions on that, though. So, okay. All right, so now we're going to cut up these red pieces to a lot finer degree, so we have lots of cool resolution when we fracture the impact of our building, right? So if I were to just delete, so if I delete by expression, I could do collide in here, and instead I'll delete non-selected. I've just isolated the parts that have a value for collide. Okay. Now the problem I'm seeing though is that it didn't really do what I wanted it to. So if I tried to fracture these, it would be a disaster because you can't really fracture things without a volume present. So we have to come up with a slightly more intelligent way of isolating the pieces that have that collide attribute present. Instead of grabbing just the points, which is what this is doing, this is grabbing each point that has collide. We need to make sure we grab, if a point is present with collide, we need to grab the whole chunk. So for that, we're going to have to step up our logic a bit. All right. So starting here, I'm going to use the connectivity. Now we've used this before. What does this do? Use this the first week with our bricks. All right, very useful.
It's going to grab things that are associated with each other?
Well, the connectivity in itself doesn't really grab anything, but it will put an attribute on it, and it will test for connectedness. It'll test for vertices sharing points. Okay, so if this point has vertices that are associated with it, and all of the other points in that structure have vertices associated with them and they connect, then it triggers in its code, the developers wrote, to say, okay, I'm connected. I'm going to give you a value of 1. Okay, you're connected. I'm going to give you a value of 2. You're connected. I'm going to give you a value of 3. Okay, so using this connectivity here, I've got an attribute called class, and now it goes, for each piece, it gives me a different number, a different attribute value. But class isn't very specific once again. So I'm going to call this large chunk ID. And that to me is very descriptive. Okay, so for each of these, I now have large chunk ID 0, large chunk ID 1, large chunk ID 2. Once again, using color to preview things. If I wanted to preview my connectivity, I would do something like rand large chunk ID plus 0.01, 2, 3. And then I could make sure that all of my different pieces had a different attribute on it. Okay? And other departments, by the way, don't understand this at all. If you're working as an effects artist in a studio and people see this up on your screen, they're like, "What's going on?" You don't even try to explain it, okay? But this is what's happening. We're normally previewing a fractured entity. Okay. Anyway, so I trust the connectivity works, so I'm not gonna preview that. Okay. I'll label it though. All right. So now I want to once again delete my collide. But now, downstream of my connectivity, these guys all have a class associated with them. Okay? So they have a large chunk ID 6, or large chunk ID 16, or large chunk ID 21. So I can use that information to transfer an attribute from these chunks to their associated chunk. And then I'll know the whole chunk that it used, okay? All right, so it's gonna get a little tricky here, all right? So far we haven't done much. We've done a connectivity, we've done a delete. That's what we've done so far. All right, so stay with me on the next steps and ask questions, okay? So I'm gonna do an attribute. Okay. I'll call this whole chunk collide. All right, and this will be a value of 1. All right, so I have some cut up pieces with a value, a whole chunk collide value of 1. All right, then over here, my entire building, I'm going to have a whole chunk collide value of 0. Okay, so now my whole building has, on this chain, whole chunk collide 0. My partial building over here has whole chunk collide of 1. All right, 2 attribute crates. Now using a point SOP, okay, my building's going to go in this part, my fractured pieces are going to go in this part. I'm going to go over in a custom attribute. See, a point SOP is great because you can set position, color, normal, but over here is custom. You can do any number of custom attributes as well. Okay, so I'm going to do a custom attribute. I'm going to set that to whole chunk collide 2. Okay, and what that means is it's going to get the values from here over to here. But that's not going to work really well yet because the point number is different. The point count is different. Like over here, it's got 225 points, and over here, it's got 1,736 points. So how does it know which thing to collide to that whole chunk? Okay, so if I were to isolate by whole chunk collide over here, okay, it's going to get all kinds of random stuff. See, because it's trying to find the first point it finds and then doing something with it. It doesn't know what to do. All right, so there's a really amazing feature of the point SOP called match by attribute, and I can use my ID, my chunk ID, to match. Okay, so I've got large chunk ID over here. That means that if it finds a large chunk ID with a value of 1 over here, it's going to set that whole thing to 1. All right, watch what happens when I type this in, large chunk ID. Aha. Okay, so I just did some logic from different point counts, and that's a great way to do it. So over here, I'm going to do non-selected. All right. So yeah, so I'm isolating whole chunk collide of 1. I've set it by that. I'll preview it here, maybe it's easier to visualize. See? So it went through and it set whole chunk collide to whole chunk collide 2. If it didn't find it, it was 0. If it found it, it was 1. Alright? So let's go through that process again. Okay. Starting off with a building. It's got a collide attribute. Let's go ahead and just delete the collide attribute just for simplicity. I used an attribute SOP, and under here it has delete attributes. Now it doesn't have anything. I'll delete CD too. There we go. Okay, so now it only has a point attribute. Okay. So starting from square one, it's just a cut up building. Okay. Oh, actually, you know what? I needed to keep my collide. Okay. Okay. So first, I test for connectivity. Now I have collide and large chunk ID. Okay. I'm gonna isolate the collisions. I'm gonna set an attribute to 1. Set a new attribute to 1. Over here, I'm not going to isolate the collisions. I'm going to set that same attribute to 0. Okay, so it goes for 0 over here. Here I only take what's relevant and I set it to 1. Now I use this ID to match these two incoming streams together. A custom attribute, I'm setting whole chunk collide to whole chunk collide 2. So it's only going to grab a value of 1 if it finds it. And if it does find it, it'll set it to the whole chunk because it's matching by the same number for each chunk, which is large chunk ID. Okay. I know you guys are going to have a bit of trouble with this. All I can say is look at the spreadsheet. Okay. The spreadsheet here. Look at this setup, because these are the nodes we're going to use. Okay, their connectivity, the delete, all that. Ask questions. This is done all the time if you're using Houdini. Now, this isn't necessarily basic, but it's done for so many things, and this is one good example of where it's done is a technique like this. Okay, so once you get it and you start using it, it'll become second nature, but the first time it's pretty hard. So let's give it our best shot. I'll be around to help. From here, I can isolate the pieces I want to break more. So I'll call these ISO Subfracture. And here I'll just do delete selected. So here on this one side I've got the going to be the high-res pieces, and over here I've got everything else. Okay, so these guys need a little bit more treatment. So I'm going to do another fracture for these. Now the problem here, it's a little bit more complicated than the first time. Like the first time, what did we do? We just like did a box, and then what did you guys do after that? Yeah, you made a volume out of it, and then you put some points in there, and it broke. Okay, but here it's a little bit more complicated because the way volumes work, the way the program determines what a volume is based on if it's inside or outside of something. So here it's going to be more complicated for the program because these things it's inside and then it's outside and then it's inside if I were to draw a line. So it's not going to make a very good volume or fracture out of this. Okay? So let me show that. Now I'm going to save here because I might crash something. All right. So if I were to do an ISO offset here, it's going to take a long time, okay, because I've got a lot more geometry. And actually, I'm impressed. It did a really good job there, but it shouldn't have. It should have broke. Okay, let's see what it does here. Ugh. Okay. Anyway, I don't want to fracture it that way. Let's just put it that way. It's, if it was anything more complicated than this, it would break and you'd have no control over your effect. Okay. So we could also try to scatter it the same way we did. Let's try 200. Voronoi. Ooh, it's not too happy with me. You know, I really shouldn't show you guys things that I don't think should work that actually work. Now that worked, whatever, it shouldn't have worked. Okay, so we're gonna do it the hard way, and it's gonna work in any circumstance. Okay. Okay. So we're gonna do a loop. Does anyone know what a for loop is in programming? Okay. So yes, that is what it is. Anybody understand that? Okay. Well. Try to explain it. We're not, because this Houdini is kind of that gray area between programming and actually doing a 3D program. So, yeah, okay. So yes. So imagine we had a skeleton. All right. So each of these bones in this skeleton needs a car wash. Okay, so you wouldn't want to do a car wash all at once or scrub it all at once, because if you just scrub the skeleton, you're always going to have places of the skeleton that aren't going to get washed properly. So instead, you're going to take the skeleton apart, and you're going to rub this thing, you know, with your washing cloth, and then you're going to put the skeleton back together at the end. Okay, so instead of just doing a blanket car wash to all the things, your missed spots, take each bone apart, wash it, put it back together. That's a for each bone loop. Okay, so for each bone, take it apart, wash it, put it back together. All right, the end result would be all the bones washed and put back together. All right, that's how a for loop works. So now we're going to do that in Houdini. Houdini has a for loop, and I have done a for loop to bones, but that's not what we're going to do it here. We're going to do a for loop to these pieces. And now I'm showing you guys this. Now we're going to be really simple with it, okay? But keep in mind, this is an advanced little node here. And a lot of people don't really know how to use it too well. So I'm not going to show you everything about it, but it's going to, you know, we're going to use it enough to where we can get the job done. All right, so this is a for each. Now, by default, it's not going to give you much. It's not going to work right now. I'm going to do for each large chunk ID. Or I'm sorry, not large chunk ID. Whole chunk. Yeah, the large chunk ID. Yeah, this guy right up here. Large chunk ID. Okay, for each large chunk ID. Okay. So instead of each group, I'm going to do each attribute value. Okay, so we've got different attribute values for large chunk ID, right? Now by default, it works with polygons. Now you can make it work with points, but that means that, you know, it means that it's only going to do our points, and that's not what we want. We want it to do our polygons instead. Okay, so instead of that, I'm going to have to transfer my large chunk ID from my points to my polygons. Okay, so if I go to my spreadsheet here, I can see that these are points up here. I can see all my point attributes. I've got position, I've got color, I've got collide, I've got all this stuff. Here's my vertices. Here's my primitives, and that's an abstract term for polygons, because polygons are something slightly different. A sphere could be a primitive in Houdini as well. So a primitive is actually more of a surface. Think about it like a surface, and each polygon is a surface. And here's a detail, and we'll ignore that for now too. Right now we just care about points and primitives. Okay, so using an attribute promote, I'm going to transfer from a point attribute to a primitive attribute. So over here, I've got my large chunk ID, transfer from point to primitive, and I'm not going to use an average either because that could get messy. It could like try to blend values. I want it to be something very exact, so I'm going to say first match. Okay. So now if I look at my spreadsheet, in primitives, or points, I don't have my large chunk ID anymore. Okay, I deleted the original. In primitives over here, now I have large chunk ID over there. There we go. Okay, so all I did was transfer from this guy in point attributes to this guy in primitive attributes. That's all I did. Okay. Now if I use my for each, now it does exactly what it's supposed to do. It loops over each of these chunks. Okay, it'd be the same thing as if I did this. Delete by expression, large chunk ID equals 1. Be the same thing as if I did that. Okay, it's doing the same thing. It's just looping through the points. Okay, or primitives, sorry. Okay, so for each attribute value, large chunk ID, and I've promoted ahead of time large chunk ID from a point to a primitive. There we go. So now if I go inside of this network, I'm going to double click to jump inside of it. This is what's called a subnetwork. So it's what you can do if, say, you wanted to make all of these nodes a subnetwork. See, now they would be a self-contained entity in here. Okay? So I'm not going to do that with these yet. Okay, but that's what a for each is. It operates inside of this operation. Okay? So for each, go inside, and here I have my first chunk. So now I can fracture it. So now I'm going to do the ISO offset. Okay. I'll just do 20. Okay. And a scatter. And I don't need that many. Let's try 20 points. Now my Voronoi, which is actually a subnetwork as well. So if you're curious about how to build your own fracture system, that's how to do it. Okay? Alright, so now I've fractured that one piece. But the cool thing is it's going to do that procedure to each piece, right? There you go. So now it's got a really good, even fracture on all these pieces. Okay? Now you might see that step as unnecessary if the other way worked, but I really wouldn't do it the other way. I wouldn't plug it directly in. It's going to mess up in production for sure. Because these models and stuff, there's so many polygons and everything flying around. You want to be able to do a loop to subfracture. Okay? So, isolate these. Promote your attribute from a point to a primitive, your ID attribute. Okay? Then loop through them and fracture each piece. To fracture each piece, you use the same procedure as we used before. Okay? So we'd use, after the each, use an ISO offset, a scatter, and a fracture. Okay? Now it will take some time to process. Notice how long this took. See? And I've looped over like hundreds and hundreds of pieces of high-res geometry, so that can, like, sometimes a fracture can take like an hour or something. You'd send that to the farm and you'd let it fracture for a long time. Okay, or you'd break it up into smaller pieces and fracture smaller pieces. All right, so this is a simple example, but if you break like the kind of stuff I did on Thor with like mountains and things like that, it must have been talking about like hundreds of thousands of pieces, and it took a while. So, yeah. Okay, so it's not too bad there, huh? Okay, so then we just merge it back together. I'm going to attribute promote the other side as well. Okay. Nah, actually, you don't have to do that. Never mind. Okay, now what happens if our flying saucer animation gets updated? Yeah, it would do it in a different part, right? So we wouldn't have to do anything. It would fracture the right stuff. So that's why this method is a lot better than going through and selecting stuff and trying to subfracture it that way. It's because if you do that a few different places in your scene becomes a mess, and you know, once your animation changes or the camera angle changes or you want the sim to change, then everything falls apart. And I've seen scenes like that, and it's not pretty. Okay, so that's why we're working procedural, which is what Houdini's good at, and we're fracturing just the pieces that we need. Okay, isolate. Promote the attribute, subfracture. You guys got it?